What is today a dry and dusty landscape in Nevada was once an ocean paradise. 240 million years ago, huge prehistoric reptiles swam here beneath an ancient sea.
They would have been truly scary animals to see in the ocean.
Now, a stunning new discovery in the desert hills has revealed evidence of one of the most ferocious creatures ever found. The sharp-toothed ichthyosaur.
This animal was the top predator in this ecosystem. This would have been the Tyrannosaurus of the oceans at that time.
I'm too excited.
And it may just change our understanding of how life evolved in Earth's prehistoric seas. A group of paleontologists are on a hunt in the wilderness of Nevada. These dry desert hills are a prehistoric graveyard. But this team isn't searching for ancient life that lived above ground. 240 million years ago, Nevada was an underwater paradise and home to ichthyosaurs, the first reptiles to leave land and evolve into ocean creatures. They know they're here because they've found them before. In July 2008, another team of paleontologists unearthed the nearly complete remains of a giant ichthyosaur in the nearby Augusta Mountains.
The ichthyosaur was about 35 feet long, and it was a pretty slender animal, and it had a long tail. The skull itself was actually pretty large. What we think right now, maybe up to 5 feet or a little more, actually, so it's a good size. The size of the ichthyosaur was definitely very surprising because what we had known thus far, the earlier ichthyosaurs were maximum maybe 10, 11 feet long, maybe a little larger than that, but 35 feet, that was definitely something absolutely unexpected of that size.
But one feature made this ichthyosaur unlike any other of its time: its teeth. They were diamond-shaped with sharp, cutting edges. This creature was pure carnivore, able to tear apart the flesh of its victims.
So when we first got to this specimen, I actually saw it right there in the field. It was just stunning, because there it was, and there was a skull that we could see. It was weathering out, and we saw the teeth being exposed. There was a few teeth that were actually laying on the surface right there. All weathered out, we could pick them up, and we saw the large teeth with cutting edges. So they were actually there, and it totally confirmed what we were hoping for. Ichthyosaur that had cutting edges on their teeth.
So this is the regular tooth type for Middle Triassic ichthyosaurs, you know, with a circular cross-section and really pointed piercing type tooth, which would have been work great on, you know, slippery prey items like fish, to just, like, you know, pierce them, hang on to them, and then swallow them and whole. And then the teeth of our ichthyosaur now really contrast this. I mean, it's much stronger. It almost has like a diamond-shaped cross-section because of this really sharp cutting edge running right over the tip. So this tooth would have worked really well, you know, just slashing through muscle fibers and, you know, biting out chunks of large, meaty, and bony prey items.
It wouldn't be necessary to swallow the prey item as whole, but actually be able to cut it in parts and eat it separately.
Yeah, just like a steak knife, you know, going right through it. I don't think that this guy had any natural enemies in the ecosystem. This was at the very top of the food chain.
The fossil was encased in dozens of pieces of heavy rock when it was found, making it impossible to carry out.
This is exciting.
That's a good one.
The remote location required special equipment. A helicopter.
The use of a helicopter in the field is rather uncommon. It's pretty expensive, and sometimes it's also pretty difficult for the helicopter pilot to actually maneuver into the area. The Augusta Mountains are rather steep, and there are some deeper canyons cutting into it, and the specimen is at the flank of one of these canyons. And there's no area that's pretty flat or so.
The helicopter came up and let down a net where we placed these individual blocks, and to protect them against bumping into each other, we also wrapped them in soft tissues and blankets.
The ichthyosaur was sent to the Field Museum in Chicago. There, the team could study and decode the fossil in greater depth. This creature was at the top of the ocean's food chain when it lived, just as some sharks and killer whales are today. But this giant reptile wasn't always a sea creature. More than 250 million years ago, it lived on land. Scientists can trace the ichthyosaur's evolution through the fossil record left behind.
Here we have one of the oldest hand of ichthyosaur. And you can see that this is already flipper shape. But if you look closely, you can see that there are 5 fingers, just like our hand. And also, each finger bone is hourglass shaped with shaft in the middle. And again, it's like ours. So you can see that this animal came from something living on land. And if you fast forward 5 million years, and you get the next stage and get something looking like this. And here, again, you have 5 fingers, but the bones are no longer hourglass shaped. They're tightly packed into squarish elements mostly.
As the bone structure changed in the hands and feet, limbs once used for swimming became more like rudders on a ship. But the changes continued, and over millions of years, ichthyosaurs began to look less like reptiles and more like fish.
Then over time, they started to modify their body plan, and it took about 35 million years before they completely became fish-shaped.
Paleontologists were shocked at the appearance of the sharp-toothed creature so early in ichthyosaur evolution. It was further evidence that the first ichthyosaurs were much more diverse than previously known.
When I first heard about sharp-toothed ichthyosaur, I was honestly surprised. We knew that some ichthyosaurs from later dates had sharp teeth, but not this early. This is only 5 million years after ichthyosaurs appeared. So that's a big surprise.
And this is just a phenomenal example of how quickly evolution can actually happen. And quickly, in geological terms, can be a few million years. For paleontologists, 5 million years or 10 million years, that's a very short period of time.
The first ichthyosaurs appeared not long after the Earth had just experienced a planet-wide catastrophe called the Permian-Triassic extinction.
The Permian-Triassic extinction occurred approximately 250 million years ago, maybe a little bit older. And it was the major mass extinction that happened in Earth history. And it had a huge effect on all life on Earth.
It was most likely caused by extensive volcanism, which then had, obviously, results on changes in the atmosphere, temperature-wise, which then obviously would have resulted in major impact on life in the seas.
Scientists estimate 95% of all marine species and 70% of all terrestrial species perished. But a new evolutionary cycle began, and the reptiles that survived took separate paths. Those which stayed on land, and those which made their way into the oceans. All life on land originally came from the oceans. But primitive fish began to develop limbs, allowing them to walk out of the seas. Now, the first reptiles were going back.
The exact reason why the reptiles started going back to the ocean is not well known. But there are a few good possibilities, and probably the strongest one is that they were after the food.
Reptiles able to adapt to the water confronted few enemies in the near-empty seas. In just a few million years, they became fully aquatic creatures and evolved into something new: ichthyosaurs.
There's no large fishes. The sharks were relatively small. They just were able to go in without any pushback, if you will, from the predators that were already there. So ichthyosaurs kind of went into this virgin environment and with no competition, and were able to take advantage of the sea life at the time and, develop pretty rapidly.
Scientists now hope to explain how this land-based reptile evolved into a fully aquatic creature. But to do so, they'll need to find the fossil that demonstrates that transition.
One of the major questions, of course, is the origin of ichthyosaurs, and to narrow down and eventually, hopefully, pinpoint the group of terrestrial animals that they evolved from, and to get a better picture of how this evolutionary process from a fully terrestrial animal to these very highly adapted marine animals took place, step by step.
In 5 to 10 million years, ichthyosaurs diversified into about a dozen different species as they conquered the world beneath the waves. But none of those ever found were thought to be savage flesh eaters. Until now. And the investigation is on to understand just what this creature is and what it may tell us about the Earth's prehistoric seas. A group of ichthyosaurs are on the hunt in Earth's ancient ocean. These creatures aren't your average carnivores. Their cutting-edge teeth make them the top predators beneath the waves. Small fish won't satisfy their appetite. Scientists believe they had the hunger and ability to eat much larger prey, sometimes even each other. Within seconds, a large ichthyosaur sinks his sharp teeth into the flesh of a smaller one. And this killer claims another victim. But scientists want to know exactly where this sharp-toothed creature fits in early ichthyosaur evolution. That information could help them solve the mystery of how ichthyosaurs evolved from some yet unidentified land-based species. The sharp-toothed ichthyosaur roamed the seas at a time when the Earth looked dramatically different.
If you'd had a time machine to go back 250 million years, you'd see this huge continental mass and a giant ocean on the other side. You wouldn't recognize it as the Earth.
The continents were fused together into one gigantic landmass called Pangaea.
It had a general C shape, like the letter C, and it was surrounded by a giant ocean as well, the Pentelassan Ocean.
All ichthyosaurs derive from one reptile that took its first steps off Pangaea and into the sea over 245 million years ago.
One could think, oh, they live in the oceans, they're just like fish, but they're actually not. They are definitely reptiles. They are tetrapods, which means that they are animals with four legs.
They evolved into fully aquatic creatures once they made their home in the ocean.
The way evolution works is that mutation happens, bringing in a new feature, and as long as it doesn't get in the way, it will stay. But if it gets in the way, then it's eliminated. So that's how new designs sort of come about.
The ichthyosaur is just one piece of puzzle in the grand picture of evolution, obviously. But ichthyosaurs are a great group to study because they start out with very simple forms and then have this explosive radiation.
Radiation is a term for the expansion of a species into a variety of new forms. It took between 5 and 10 million years for about a dozen species of ichthyosaurs to evolve from that first land reptile. By then, there was no turning back.
They became unadapted, if you will, to coming back on the shore. Over a period of millions of years, their bone structures simply would not support their body. If they were beached, they'd be like a beached whale today. If they couldn't wiggle their way off the beach, they'd be dead in a matter of hours or a couple of days just from overheating or suffocation.
The sharp-toothed ichthyosaur had an advantage over other marine life in the ocean. It used its size and cutting-edge teeth to rise to the top of the food chain.
In any group of animals, you'll find a variation. And if a group of animals has a mutation, if you will, or a change that produces teeth that are more efficient for a certain kind of feeding, those are the animals that are successful in living and reproducing. And the animals simply live longer, reproduce more, have more descendants.
It's definitely an important ecological role that was waiting to be filled by some animal. And obviously, in this case, it was for the first time a marine reptile, and specifically this really large ichthyosaur.
Scientists look to solve the mystery of where the sharp-toothed creature fits in ichthyosaur evolution. Now, an expedition is heading to Nevada in search of more answers. Hard evidence only a dig can provide. Ichthyosaur remains have been found all over the world. But one place has been a magnet for paleontologists for more than a century: Fossil Hill.
Fossil Hill is historically very important because it's actually the site where they found the first ichthyosaurs. They collected quite a few marine reptiles there.
So is that 30? Is that the paddle?
Yeah.
Okay.
Fossil Hill is only 50 miles away from where the sharp-toothed ichthyosaur was found in 2008.
No, it's going to close.
Now, Ryosuke Motani, along with colleagues Lars Schmitz, Pat Embry, and Neil Kelly, have come to Fossil Hill in the hope of learning more about the sharp-tooth and other early ichthyosaurs.
The Augusta Mountains, Fossil Hill, are actually rather close to each other, about 50 miles apart in northwestern Nevada. Both localities expose rocks of approximately the same age. And we know both localities have delivered fossils, fossil ichthyosaurs. And so there is a chance that at Fossil Hill we'll find other ichthyosaurs that might tell us and help us to resolve the mystery of our sharp-toothed ichthyosaur.
A team of paleontologists is heading into the hills of Nevada, searching for evidence that might help them understand more about the sharp-toothed ichthyosaur. Uncovering a second specimen would be the discovery of a lifetime. But the holy grail for paleontologists is to find the fossil of the missing link, an early ichthyosaur that lived during the time they transitioned between land and sea.
We don't know exactly how long it took them to get used to the life in the water completely, because the first ichthyosaur fossil that we find is already adapted to the life in water.
But getting to their destination, known as Fossil Hill, isn't easy. The trek is an arduous drive on unpaved roads and dangerous terrain.
Fossil Hill is located in north-central Nevada in the Humboldt mountain range. Its elevation is a little over 5,000 feet. It's considered high desert. We get cold, very cold winters and hot summers. You should have a four-wheel drive to get close to the property. The topography is fairly steep. You never know what kind of weather conditions you're going to expect. Some you can have dust storms, you can have blizzards, blazing sun. You just never know what to expect out there.
Understanding the evolution of any prehistoric species requires a series of fossils that often need to span millions of years. But fossils are very hard to come by. The creation of even one fossil is an event of incredible odds and requires a great deal of luck.
Becoming a fossil is like winning the lottery for the first thing. It's very rare for any animal's carcass or body to survive long enough to be buried and then preserved as a fossil.
Over millions of years, the remains are protected and preserved as the sediment layers build and leave it deeper and deeper beneath the surface.
It has to survive long enough to reach an area where it can be covered up. It has to remain undisturbed for a long enough period to have these sediments build up on top. So, it's a calm environment. The bones don't get spread around. You don't have a lot of scavengers tearing the carcass apart.
The sharp-toothed ichthyosaur must have died in perfect conditions when it fell to the Nevada seabed 240 million years ago, because a nearly complete skeleton was recovered in 2008.
It is very rare that we actually find a complete skeleton, like including every single bone that there was. I mean, this is almost never happening.
The sharp-toothed ichthyosaur lay deep beneath the Earth's surface. Then, over millions of years, continental plates buckled and lifted the western United States. Terrain once underwater transformed into the Nevada mountains. Gradually, rock and sediment was exposed, until eventually the fossilized remains became visible at the surface.
But it's not only winning the lottery for a fossil to become a fossil in the first place, it's winning the lottery again to actually be found by someone that is able to collect the fossil before it turns to dust. When they weather out and you get frost, freeze, and rain and wind and everything else attacking these bones, they'll be destroyed in the matter of 2 to 3 years.
The nearly perfect preservation of the sharp-toothed fossil gives scientists a good chance to discover where it fits in the ichthyosaur evolutionary timeline. But the discovery is only the beginning. The process next continues in the lab.
So now that we have this ichthyosaur here in the Field Museum, it's not entirely prepared yet, and it's a large specimen. We have 10 to 12 meters of body length, so it takes a lot of time to prepare it.
The fossils of dinosaurs and other ancient creatures in museums did not begin their journey as pristine bones ready to be assembled like Legos. At Chicago's Field Museum, experts remove the bones of the sharp-toothed ichthyosaur from the solid rock tomb that encased them for over 240 million years.
There are several challenges on this ichthyosaur project. Number one is the size. It's big, so it's really time-consuming to do.
Akiko Shinya is a fossil preparator at the museum. It's her task to carefully help reconstruct the ichthyosaur from what looks like a pile of rubble. The ichthyosaur is encased in many pieces of solid rock. Its reconstruction becomes a prehistoric jigsaw puzzle. And carving bone out of rock is extremely delicate and time-consuming work.
Most of the tools we use are hand tools like these ones. So essentially, it's like a miniature jackhammer that you see in the road construction. So this part goes back and forth in piston, and it just knocks the rock away from the fossil. And hopefully there is a good separation between the rock and the fossil that just chips it right off. I need to work on this part. Nadia in New York told me that this part is quite important. They want to know how the bones are connected to bone.
Akiko's first task is to find the cranial sutures, which are the connection points between the different pieces of the skull. But 240 million years can blur the line between fossil and rock.
Some parts of the ichthyosaur are very similar color. Rock itself is somewhat gray, and then maybe a little bit darker, maybe a little bit lighter. It contains lots of shells because the ichthyosaur was in the marine environment, so it has like a lot of shells and snails and those clam bones, and they are very similar to ichthyosaur itself. So it's hard to differentiate, yeah.
They'll need the entire skeleton in order to determine where this creature fits in ichthyosaur evolution. But so far, only 60% of the sharp-tooth fossil is prepared. While this painstaking process goes on in Chicago, the team in Nevada makes an unexpected discovery.
Is this a tooth? Is this where a tooth was?
The search continues in Nevada. Fossil Hill is well known for the dozens of ichthyosaurs found here over the past 100 years. But so far, the sharp-tooth specimen is one of a kind. And paleontologists need more evidence to better understand the discovery's impact on evolutionary history.
One of our main wishes would be to find another sharp-toothed ichthyosaur. It's not uncommon that we only have one individual per species, so it's even more important to study that specimen in great detail, and we have to put in more effort and go out in the field and do more field work, find more specimens, and be lucky to find more.
The potential for finding ichthyosaur fossils is very great. I would say there's somewhere around at least 100 ichthyosaur specimens that have been found around Fossil Hill.
Not long into their search, the team finds something located at the base of the hill. Ryosuke Motani spots a discoloration in a piece of rock. These small black lines in the rock might be considered just another mineral to the untrained eye. But the ability to distinguish a fossil from rock is an art for paleontologists. Motani instantly recognizes this is an ichthyosaur fossil.
So here's a quiz. Which part of the body is this from?
What region of the vertebral column?
Yeah.
Oh, wow, okay.
So here's an isolated backbone right there with the hole in the middle, which is actually not the hole, but it looks like that here. Then we have the rib, and the rib around here. And what else? Have you spotted anything else?
Judging by the size and shape of its backbone, Motani believes this ichthyosaur fossil dates from about 245 million years ago. Not old enough for this investigation. But it's not just the creature's anatomy that helps determine its age. Its placement on Fossil Hill is also an important factor. Paleontologists can determine how old a fossil is depending on where they find it. As the team climbs the slope, they head deeper and deeper into the past. Just a bit further up, they locate a second ichthyosaur fossil. Its smaller size indicates it's an older, more primitive creature.
So these are, as you can see, small ichthyosaurs.
Yeah, so much smaller than the one we saw before.
Right, right. So, and this one's older too, because as we walk down that way, up that way, along the hill, we are traveling back in time, older and older.
Okay.
So we saw one that's bigger back there, but this one's probably less than 1 million years older.
One of the nice things of Fossil Hill is that we can walk through time, essentially, right there. So from the base of the hill, we can walk up, and we cover about 5 million years.
The forces that created this time machine are plate tectonics.
The continents are sitting on a somewhat liquid, not partially molten material of the inner of the Earth, and they're floating on that surface.
And over time, continents drift. When the first reptiles left land and evolved into ichthyosaurs, there was only one continent called Pangaea. Then Pangaea began to break apart.
These plates move maybe up to 5 centimeters per year, but if you accumulate that over millions and millions of years, you can cover a lot of distance in that time.
The Earth itself is a very dynamic entity, and that we actually have an Earth that looks like today is maybe only 50, 60 million years ago.
The bottom of the sea was pushed upward and transformed into mountains over millions of years. And when the seafloor rose, it took fossil evidence of its watery past. Toward the crest of Fossil Hill, the team discovers what may be a key artifact of these tectonic forces. Pat Embry locates an ichthyosaur fossil embedded in a small patch of rock jutting out from the side of the hill.
What do we have? Oh, wow. Look at that.
Wow, that's great.
Yeah. It's very similar in shape. Look at that backbone. It's not that wide in diameter. It's sort of really cylindrical still. That's the basal feature. But this one's pretty complete.
So which way is this facing? Where's the head?
That's, I think, head that way. And the hip must be around there, somewhere hidden.
Yeah.
So if we expose the rest, we might see more.
So gauging from this vertebrae, can you tell how long this guy was?
Yeah, it would be about, I'd say, 7 to 8 feet. That's the total length.
Although it's not a sharp-tooth fossil, Motani is convinced they've found some type of ichthyosaur. And it's older than what they expected to find.
We got a vertebrae right here.
There's
another one here.
Yeah, but that's the clearest one. Yeah, this one is not like a disc in the later ichthyosaurs. This is much more like cylinder. That's really nice.
Yeah, it's fairly long.
It's a skeleton.
The narrow, cylindrical shape of the vertebra dates the fossil a few million years before the sharp-tooth ichthyosaur. Thinner backbones in early ichthyosaurs suggest that they swam by moving their entire body like an eel. Scientists believe this motion allowed for quickness and maneuverability in shallow waters. But the backbones became stronger as ichthyosaurs evolved. The sharp tooth had a thick disc-shaped vertebra and swam by swinging its huge tail back and forth, giving it the strength needed to hunt in the open ocean.
And the specimen that they found in the Augusta Mountains, the vertebrae, how is it shaped?
Oh, it's a disc shape, right?
Yeah, they're disc shape. Yeah, the typical ashtray shape.
So, but different than this one.
Yes. Yeah, clearly different.
This is really primitive.
Yeah.
This fossil is older than expected, but half of it is still buried in the side of the hill. Paleontologists are on the hunt for evidence that could help them solve the mystery of how the ichthyosaur evolved from a land creature.
So I'm getting at this corner because there might be the skull.
But almost 1,300 miles away, fossils of a much later giant marine reptile have already revealed more about that creature's own transition from land to sea. The creature is called a mosasaur, and it once swam in what is now Kansas, in a body of water called the Western Interior Sea. Large limestone columns hold evidence of this watery past.
The rocks that I'm walking on right now were actually the bottom of the Western Interior Sea about 85 million years ago. The Western Interior Sea at that point stretched from, say, Missouri on out to Arizona, Nevada, all the way from the Gulf of Mexico on up to the Arctic Circle. It was a vast mid-continent ocean about the size of the Mediterranean Sea. Where we're standing would have been about 600 foot deep.
But ichthyosaurs did not rule these waters. They had been extinct for over 15 million years.
We don't know why ichthyosaurs disappeared at this point of time. They may have just reached the end of their successful run, and then the last forms disappeared from the fossil record.
A variety of factors can lead to the extinction of a species. Climate change, competition from other groups, or possibly collapse of food resources. But nature abhors a vacuum, and another sea reptile emerged in the oceans of the world. Mosasaurs.
These were very large, lizard-like marine reptiles that grew to lengths of over 30 feet and were capable of eating just about anything else that swam in the seaway. It was a very dangerous place to be alive at that time.
They're lizard relatives, very successful group. They had a very mobile jaw joint, so they could open up their jaws extremely and had a huge gape. A very successful group.
At 35 feet long, the sharp-toothed ichthyosaur was the largest creature in the ocean 240 million years ago. And of all the mosasaurs, the one who could easily match the sharp-toothed size and ferocity was a species called Tylosaurus. The Tylosaurus was huge, the length of a modern-day school bus, larger even than one of the most feared dinosaurs of the time.
You know, these animals were, in lengthwise, were bigger than the largest Tyrannosaurus, and they were able to eat anything and everything that they encountered, including other mosasaurs or turtles, big fish, birds.
For 20 million years, mosasaurs dominated the world's oceans. But their reign would also come to an end in yet another extinction event. 65 million years ago, an asteroid the size of Manhattan screamed through the heavens and slammed into Mexico's Yucatan Peninsula. The impact sent up a gigantic plume of fiery ash, equivalent to the explosion of 100 million megatons of TNT, or nearly 1 billion times the size of the Hiroshima atomic bomb. Dust and debris blocked out the sun, sending temperatures plunging below freezing. 75% of all life on Earth was wiped out. An event we call the KT extinction.
KT extinction event was a massive extinction event in Earth's history. It had a massive impact on the atmospheric composition, on temperatures, on obviously life in the oceans and on land.
The most famous casualties of this disaster were the dinosaurs. But ocean life suffered a similar fate. It signaled the final blow for the mosasaurs and many other marine life forms.
The big rock falling out of the sky didn't kill them directly, but it may have been responsible for wiping out this extensive food web that supported, thousands of these very large predators. And when that food disappears, the mosasaurs are basically going to starve to death.
But the KT extinction opened the door to a new migration from land to sea, this time by mammals. Fossils show a creature much like a tiny deer may have evolved into today's whales. The evolutionary journey from land to sea is emerging for whales and becoming clear for mosasaurs. But scientists have yet to find the ichthyosaur's missing link. Now, the expedition team makes a discovery they hope could help give them an answer. Near the crest of Fossil Hill, a team of paleontologists have made an exciting new discovery: the remains of an ichthyosaur. And although this fossil isn't a sharp-toothed ichthyosaur, no one is disappointed. It appears to be 5 to 6 million years older than the sharp-toothed specimen.
What gives it its primitive characteristics?
So one of the things is the vertebra that we just talked about, this backbone, that's cylindrical, not disc-like yet. And then the rest are actually not difficult to see at this point, so that's why I want to see it exposed.
So we should move all this off and get it swept off?
Yeah, it would be nice.
All right, let's do it.
But they need to work fast. The wind is kicking up, and a storm is on the way.
Oh, sorry. I should have secured the bones. We're in a hurry.
We'll wash it off.
I'm too excited.
Yeah, I kind of want to expose the entire thing now.
Yeah.
The team gets a closer look at the fossil after excavating the outer edges of the rock.
I guess there's no end to it, really. Yeah. So we have to stop somewhere.
Wash and see what we have?
Yeah, that's one way, yeah. Then we'll know where we are.
The difficulty of distinguishing between rock and fossil is a typical problem. Pat Embry washes down the rock to help visually separate out the bone. But exactly what kind of ichthyosaur this is remains to be seen.
Look at that. Awesome. There's way more ribs than we thought there were.
So that's the backbone that we saw earlier, and these are the ribs that we saw. Some bones here and there, but they're not very well defined. So it's difficult to tell at this point what they are. So these things are called gastralia. So these are not the true ribs, but these are additional rib-looking fin that covers the belly of the animal there. We don't have it, but the reptiles do have it. So that's what these are. Yes, so we have to find out the extent of this animal, how far it goes back, and if the skull is there or not. Then once we exposed everything, then we can secure the surface and collect it.
So would you say this is one of the oldest ichthyosaurs in North America?
Oh yeah, for sure. There's no doubt about it.
I think it would be totally worthwhile getting it out of the field. It will take a lot, though.
Yeah.
They'd like to remove the fossil and get it to the lab. But with a storm brewing and a need for heavier equipment, recovery will have to wait. The team holds out hope that this ichthyosaur could in fact show an early transformation from land to sea creature, with a limb resembling a hand more than a flipper.
The jackpot might be right there, actually.
If it's just like the other oldest ichthyosaurs, then we'll see flippers. But there's a chance that this might be even more primitive, right?
We might have to go a little bit further back in time to find a more basal ichthyosaur, more primitive ichthyosaur that does show that more terrestrial land feature that we are looking for.
Yeah, and there's probably only one place in the world that has it. Just like the whales, all the earliest whales come from Pakistan. That's the only place, because they entered water there. For ichthyosaurs, we don't know where they entered the water. Could have been here, could have been somewhere else, but if it was here, then there's a chance that we find something really primitive. So that's what we want.
The discovery of this early fossil is one piece of the ichthyosaur's evolutionary puzzle. But no one is sure what role the sharp-toothed creature plays in that story. The answer must wait until it can be fully prepared and studied.
At this point, our investigation of this animal is just not complete enough to make any really firm conclusions of to which group it belongs within ichthyosaurs. So we'll have to await all the data that we collect to investigate this further.
However, it is clear that the sharp-toothed ichthyosaur and its role as the top predator has changed what scientists thought they knew about these first sea reptiles.